Happy Friday. How are you? Hopefully, you are doing well. And I am using a better recording software, whatever. And hopefully, I'll be back on Monday. That's all I have to say there as an introduction. I'm sure it's been a long week, and I can't wait to be back. And you haven't really been sending me a ton of emails. Your scores are looking good. So thank you for working hard. I do appreciate it. Today, we are going to do the last two bits of information that I wanted you to review from this section about solving. We're going to solve absolute value equations and quadratic equations. And I posted this, but you don't have a way to, print it right now. But if you wanted to open it in Cami or something, you could do that. It might be tough, dual screen, but maybe a partner can show the video. Anyhow, happy Friday, and let's get started. The absolute value we talked about, I think, on the first day of school, that the absolute value of a number represents the distance that number is from zero. And it is up to you to perform that operation. So 1, 2, 3, like the number 3, and then 1, 2, 3, the number integer -3. They both are an equal distance to zero. Two integers will always have the same absolute value because zero has opposites on either side of it. And so if you have a problem like the absolute value of x is 9, it's your job to identify that there are two different x values that could be the solution to this. I like to say that you're getting rid of the absolute value because very often when you solve, we talk about canceling things and doing the inverse and stuff like that. So it's not really like you're canceling the absolute value, you're interpreting the absolute value. And you know that there are two numbers that always have the same absolute value. And so there are different approaches to solving. You always want to consider two cases. And the two cases would either be that the x is the positive value of what is shown on this side of the equal sign, or the x is the negative value. And so that's what I do is I write two different equations where the thing on the inside is either positive that or negative that. If it's a simple equation like this, absolute value of x is like a number, then you don't feel like you're solving much at all, and you're just understanding absolute value has two possible solutions. So I always use the term attack when I solve equations. I feel like I'm attacking and I'm trying to get to the x, and then I'm taking everything away until I get to the x. And absolute value feels like walls, right? Like you're trying to get to the x and there's walls. And so I always say, if you want to break down the walls, it naturally, you see my hands go like this. Like you have two solutions: either whatever's inside is equal to the 10 or whatever's inside equal to the -10. That's how you break down the walls and solve. So 2x minus 2 equals 10 is going to give you one solution, and 2x minus 2 could also equal -10. And so what you see is the 2x minus 2, I kept it exactly the same. And the 10, I made one of the 10s exactly the way that you saw in the problem as a positive 10, but then there's a possibility that it could be -10. I also see people do the opposite of the 2x minus 2. I just think it's easier to do the opposite of this versus the opposite of what's inside the absolute value. From here, the steps are the same, right? Add 2 to both sides. I'll get 12 and then divide by 2, and I'll get 6 as one possible x. But if I do those same operations, add 2 to both sides on that first step, because I'm adding 2 to a -10, I'm not going to get, that same 12 that I did over here. So that, in a nutshell, is how to solve absolute values. And I'm just going to take you through some interesting things that could come up. So, before you split into two separate cases, it's this absolute value that could potentially be two different things. And so anything outside of the absolute value, you could deal with that like you normally would deal with, like if you're subtracting 4 and you're solving an equation, you would add 4 to the -4 and it would cancel it off that side. So that you go about your business, like I said, trying to get to the X, trying to get to the X, and then, oh, it's in those walls. And so you say, at this point, I have two cases. Either X plus 6 is equal to 14, and it is also a possibility that X plus 6 could be equal to -14, and that's the second case. So you hear me using the word and or, those two words synonymously. If it is your job to find solutions, there are two solutions. So you could say and would be more appropriate. This and this are the solutions. But I'm not a huge stickler on that. I'm going to continue solving. X equals 8. X equals, this side would be -20. All right, so I've got 3 for you to try to do. If you could pause this and try to do it, please. You'll see me count. Did you pause it? If you didn't pause it, please pause it and try to work those out, because I'm just going to get right into what I think the answers are. I'm going to try to do it in my crazy head. So let's see what I get. I think 9 is going to be one of the answers, and then -3 is going to be the other answer. So if I, in my head, 9 minus 3 is 6, and then I'm subbing this in, -3, take away 3 is -6. And so I'm trying to get two different kinds of 6s in there, a +6 and a -6. This, in my head, 3 plus 2 is 5. So X could be 2 and X could be -2. And then isolating the absolute value tells you the absolute value needs to be the number 7. And so X could be 2 and that would give me a +7. And then X could be -12 and that would give me a -7. So yay! Because distance is defined, how absolute value is defined, the absolute value is always positive. And so there's some tricks. Sometimes equations may have no solution, and you might not catch it if you're just going about your business and doing positive negative, because you'd be like, oh, X is 1 and X is -1. So you have to slow down and make sure that the absolute value is equal to a positive number before you proceed. If you already see the absolute value is equal to a negative, you're supposed to say no solution. Now I'm looking at your answer book, and they have this thing called the empty set. So if you did set notation in your other classes, I did notice that your textbook is showing solutions like that. Like they'll do these little curly brackets, and they'll include all the numbers that are solutions. Same on this one. If I just went and subtracted 10 on both sides, you'd reach the conclusion that the absolute value of X is negative, but it can't be. Once again, empty set, no solution. You can write either one for me, I don't care. And then same one, X plus 7 equals -2. Don't do that. I won't accept that one. No solution. There's no such thing as negative distance. All right, ladies and gentlemen, you think it's done, but it's not. I still have one more scenario. If you come across this, you might be like, wait a minute, this is different. And so this is my third case. So at the beginning, you would say, sometimes students, so every time I have absolute value, I'm going to have two answers. Well, no, because sometimes you have no answers. And sometimes it's possible that you do actually only have one answer. And that's because you see when I try to solve this next example, I'm going to subtract 7 to both sides to try to isolate the absolute value. And then I get that the absolute value of x is equal to 0. And the distance from 0 is 0. So if you ever get that the absolute value is equal to 0, then there is one answer. And that answer solution is that x equals 0. In the next example, I don't have just absolute value x. So anything that's inside the absolute value, that's when I break this down and I create two separate equations. But weirdly, use no such thing as negative 0. So when you make two solutions, it's like positive this one, negative this one. But there is no such thing as negative 0. 0 is right in the middle of the positives and the negatives. And so there's only one solution of this, and it is x equals 3. So I have a few for you to do here with a couple of questions. Again, if you could pause it, copy these down, and try to answer it. There are 1, 2, 3, 1, 2, 3. Forgot to renumber them. 6, 7, 8 questions for you to answer there.